Welcome to Chem Help ASAP. Now, when I talk about hybridization, personally I find atomic orbitals to be sort of an abstract idea. So to make this a little more easily grasped, I want to talk about something more concrete, like ice cream. So on the screen we have cream and fruit written 3 times. This is to represent 1 volume of cream, let's just call it a liter, and then 3 volumes of fruit. And we're 3 liters of fruit, and we're going to use this to make ice cream. Now we have 3 different options. We can take our cream. We're always going to need to mix in cream in our recipe. And the question is, do we want to mix it with 1 of our fruit volumes, or 2 of our fruit volumes, or all 3 of our fruit volumes? So we're going to have 3 different recipes for this. So option number 1, let's take our cream and mix it with fruit. 1 fruit. And when we do this, we're going to get 2 volumes of cream and fruit together. In this case, 2 liters. Plus, we're going to have 2 single leftover amounts of fruit. We could also take our cream and fruit and mix actually cream with 2 fruits. So we will get 3 volumes of cream and fruit. I'm not going to write F twice. I'm just going to say F squared, or F2, plus we would then have 1 leftover volume of fruit. Or we can take our recipe, and let's say we're serving someone who just loves fruit and they don't want a lot of cream with their fruit, and that's fine. We'll mix this and get all 4 volumes, 3 volumes of fruit plus a volume of cream, and we'll call that CF3. And of course there's no leftover unmixed fruit. Now this sounds kind of silly, and we're mixing cream and fruit to make ice cream, but it's not all that different from what we talk about when we do hybridization. So here's our ice cream model. Let's talk about a hybridization model. And we will have space to write that, thank you. And so we're going to take, and then instead of 4 volumes of fruit, we're going to have 4 orbitals, an S and 3 Ps. And there are 3 ways that we're going to be able to mix this. We will always, just as with ice cream, we always started with the cream. In hybridization, we will always include an s orbital in our hybridization model. So if we take our s orbital and mix it with 1 p orbital, we will get 2 new orbitals plus 2 unhybridized p orbitals that weren't used in the pictures. Notice that we started with 4 orbitals, and we get out 4 orbitals. Or we could take our s orbital and mix it now with 2 p orbitals. And that will give us 3 hybrids. 3, we'll call them sp2 hybrids to represent the ratios of s and p orbitals in the hybrid mixture. And we will have left over an unhybridized p. And then lastly, just like we saw with ice cream, if we take all 4 orbitals and mix them together, we will get 4 equivalent orbitals out, and their ratio is 1s to 3 p's, and sp3 hybrids. So just as we can mix physical objects into new things, we can mix orbitals in the same manner. Orbitals are very abstract, but if you think about them as simply being objects, and we're mixing objects, whether it's ice cream and fruit or colors of paint, you can understand the exact same ideas. As hybridization, we're mixing these objects and making an equivalent number of objects with a combination of properties.